Okay, so this is E2.6, which is all about increasing, decreasing, and constant functions. We're finding the intervals where it's either increasing, decreasing, or constant. Self-explanatory, right? So I'm going to go ahead and give you the three definitions, and then we'll look at some examples. So the definition of an increasing function, okay, is a function f is said to be increasing on an open interval if for all a and b in that interval, if a is less than b, that implies that f of a is less than f of b. So I'm going to go ahead and just draw a picture here to help with our understanding. This means we have this interval from a to b where our function, and I'm just going to draw a random one, okay, maybe it looks something like this, I don't know, okay, but notice from a to b all my y values are getting larger or increasing, okay? So that means over here that this y value f of a is less than my y value f of b. So what that means is for every little x in here in between a and b, each preceding y value gets greater, then this is increasing, okay? And we always write our intervals of increasing and decreasing in terms of our x. So we look at our y's to see if it's increasing. Like here we can see our lines going up. So if our y's are going up, we write the interval of our x's that corresponds to that, those y's. So this would be an increasing interval from A to B. And we don't include our start and end points, okay, or our end points of that interval. It's an open interval, so we just leave A and B both with parentheses when we write our interval notation for that, okay? So that's increasing. Decreasing looks the same, but now, as you would guess, our y values will be decreasing, so our line should be going down. So here we have the same kind of picture. Here's A, here's B, and this time, I don't know, maybe it looks something like this, okay? So notice up here at A, all my x values between A and B, okay, if I pick any of these, notice their corresponding y values are getting less and less and less, which means that f of A is the largest y value, and then they keep decreasing all the way down to f of B, which is the y value for my B point, okay? So this would be a decreasing interval from A to B. Again, we're not writing y values, we're writing the x values that correspond to those decreasing y values, and we always use parentheses, okay? Our last one is a constant interval. Constant means our y's aren't changing. So if I wanted to draw a picture, sorry, it's a little crooked, A to B, maybe it looks something like this, okay? But every x value between A and B, notice, has the exact same y values. The y values are remaining constant. So f of A equals f of B. And I have a typo up here. In my definition here, it says a function f is said to be constant on an open interval if for all A and B in that interval, A is less than B implies that f of A is equal to f of B. Sorry, that should not be a less than, that should be an equal to. So sorry about my typo. Okay, so increasing, my y's are going down, increasing, my y's are going up, decreasing, my y's are going down, constant, my y's are staying the same. When we write our intervals to represent those y values, we always use our x values or our domain values, and we always use parentheses on our beginning and end points. Okay, so this would be the constant interval from A to B. So let's go ahead and look at one. This one's already graphed for us. All we have to do is identify where this is increasing, decreasing, and constant. So the first thing I'm going to do is just identify all the points where it changes from one to the other. So notice it's going to change from my first dot to my second dot. My y values are going down, right? My line's pointing down. So this is a decreasing interval. And then from that second point over to my third point, okay, so over to here, notice my y values are staying the same. So this is a constant interval. And then, I don't know if you can see this dotted line on the y-axis, okay? But from my third dot over to my fourth dot, notice my y's on this little half of a parabola are going down. So this is another decreasing interval. And then from the vertex of that little half parabola, which is the y-axis, over to this next point, notice all my y values are increasing. My line's going up. So this would be an increasing interval. And then my last interval over here is going to be constant. So now I know each piece, but I have to write it in terms of its x values. Okay, so I'm going to go over here, and that means it's decreasing. Notice I have two decreasing intervals, and I look at their x values. So that means it's decreasing from this x value to this x value. Okay, so here it would be decreasing from -11 to -9. Notice I always use parentheses because I don't include my endpoints. And it's also decreasing over here from this x value over to this x value, which is from -3 over to 0. So from -3 to 0, it's also decreasing. Then I want to write my intervals where it's increasing. Okay, I only have one. My increasing interval, notice is this one. It starts right here at the y-axis and goes all the way over to here. So all these x values, their y values are increasing. So that interval would be from 0 to 6, I believe. Yes. Okay. And then I want to list my interval. I don't know why my lines didn't show up here. Okay. And then my last interval is my constant intervals. Okay. So the places where my y values are constant, remember I write them in terms of, let me see if I can get a, oh, that'll work. Okay. We write them in terms of their x value. So from this x value over to this x value, I have a constant interval, which is from -9 to -3. And we also have a constant interval over here from 6 on out. Okay, so that means from 6 on out to positive infinity, that piece of the line is always going to remain constant. Okay, so we look at the y values to determine if it's increasing, decreasing, or constant. But then once we have the y values, then we write our intervals in terms of our x. Okay, so that's what our little reminder down here says. Okay, when we're finding the intervals of increasing, decreasing, and constant, you look at the y values behavior, but the intervals are stated in terms of the domain, which is the x values. Okay, so let's look at one. So all these, what we're going to do is we're going to have to graph it ourselves. That last one was graphed for us. On all of these, we're going to graph it ourselves, and then once it's graphed, we determine the intervals where it's increasing, decreasing, and constant. And I'm also going to do domain and range, because I'm pretty sure this homework asks you to find that as well. Okay, so this first one is f of x equals -3. Remember, f of x is the same as y. So this is just the line y equals -3, which remember is just a straight horizontal line through -3. So I go to where y is -3, which is here, and I just draw a horizontal line through that point. Okay. So notice this line is only staying the same, right? All the y values on this line are the same, which means that this is a constant line. There's no other place where it's going to increase or decrease. So that means that it's constant from -infinity to positive infinity, because I do it in terms of the x values, and no matter how long this line goes, I'm going to have it consistently constant. Okay, so this is a constant interval from -infinity to positive infinity, and then I'm going to go ahead and list my domain and range. Okay, my domain is going to be from -infinity to positive infinity, because notice this line goes in both directions, left and right, keeps going. And my range for this one is going to be only the y value that it has, which the only y value it has here is -3. So I'm going to put it in set notation since there's only one. Okay. All right. So let's look at another one. Pulling in some old functions from the past. Okay. Again here, f of x, if it helps you write it with a y, y is equal to -2x plus 7. Now we could see this as the identity. We could say that the parent function is x, you know, which looks like just straight through the origin, and then we could vertically stretch it, we could reflect it, we could move it up 7, or we could just see that this is just going to be a straight line, right? Anytime we have an x to the first power, this is just going to make a straight line. Remember when we graph straight lines, we like it to look like y equals mx plus b, because then we know our slope and we know our y-intercept. So for this one, my slope would be -2/1, and my y-intercept would be 0, 7. So I'm going to use that to graph it. I'm going to go up to 7, which is here, And then I'm going to count my slope. So I'm going to go down 2, forwards 1, down 2, forwards 1, down 2, forwards 1. And you can keep going. I have a good enough picture now. And I connect my dots. So notice the whole reason I graphed this was to figure out my intervals of increasing, decreasing, or constant. And this line, unless it's horizontal or vertical, right, or it's a piece of a piecewise function, lines should do the same thing the entire time. So here, this line is pointing down as I go from left to right. Notice my y values are decreasing. So this means that this is a decreasing function, okay, across the whole entire line. So that means it's going to be decreasing from negative infinity to positive infinity. And then I want to go ahead and list my domain and range. Okay, my domain on this, the furthest it's going to go to the left is negative infinity. The furthest it's going to go to the right is positive infinity. Okay? And the same thing with my range, because this is going to keep going south and it's going to keep traveling north. So negative infinity to positive infinity also. Okay? Not too bad, maybe? Let's look at another one. Now this one is reminiscent of the last section we did where we had to do our transformations. So the first thing I'm going to do is identify my parent. Okay, my parent function here is the absolute value of x. Now that I have my parent function, I'm going to go ahead and just make an xy table so that I have my starting points. Okay, absolute value function makes a v, so I'm going to plug in a negative 2, 0, and 2 so that I get a negative, a 0, and 2, so I get that nice v shape, which when I plug them into the absolute value gives me positive 2, 0, and positive 2. And then I'm going to identify the transformations. Remember, we do them in HS-RV order, where H is horizontal, S is stretching and compressing, R is reflection, and V is vertical shifts. So I have three things going on. First thing, I have a negative outside the function. If the negative is outside the function, it's negating the y's. If I negate the y's, that's a reflection about the x-axis. Okay, so I'm going to put here, we got that by negating the y's. Okay, then I have this minus 5 inside the function. When I subtract 5 inside the function, that's going to move me to the right 5. So I'm going to add 5 to my x's. Okay, and then this last thing, I have a plus 1 on the outside. Plus 1 on the outside is going to move me up 1. So I'm going to add 1 to the y's. Okay, I don't have any multiplication, so that means I don't have any stretching. So the first transformation I'm going to do is my horizontal shift. So I take my parent function table here, and now I'm going to modify it so it represents x minus 5 inside my absolute value. Okay, to move it to the right 5, I'm going to add 5 to my x's from the previous table. So I'm just going to add 5. So that gives me negative 3. Not negative 3, positive 3. 0 plus 5 is 5, and 2 plus 5 is 7. Okay, my y's stay the same. Then my next shift is to reflect it about the x-axis. So now my function looks like negative absolute value of x minus 5. Okay, and to do that, all I do is negate my y's. So take the y's from the previous table and change the signs. Okay, so my x's are still 3, 5, 7. My y's are now negative 2, 0, negative 2. And then the last thing I need to do is move my function up 1. To move it up 1, I'm going to add 1 to my y's. So my y's that I just negated, now I'm going to take those and add 1 to them. My x's are still 3, 5, 7. When I add 1 to my y's, I get negative 1, 0, negative 1. So I'm going to go ahead and graph my function. Hopefully I end up with a nice V. Over at 3, I'm down at negative 1. At 5, I'm up at positive 1, and at 7, I'm back down at negative 1. So notice I did end up with my nice little V shape. Okay. So remember, the reason that we're graphing this is so we can find the intervals of increasing, decreasing, and constant. So here I have 2 because at the point of the V it changes directions. So I'm going to go ahead and just do a dotted line right here. So notice up to that dotted line, my y values are increasing. Okay, and then from the top of that V on out to the right, then my y values are decreasing. Okay, so that means I have an increasing interval from negative infinity up to the point of that V. And notice we write it in terms of its x value. So that's at x equals 1, 2, 3, 4, 5. So from negative infinity to 5. it's increasing, and then it turns, whoa, can't write decreasing, and it starts decreasing from 5 on out to infinity. Okay, and then I'm going to go ahead and do domain and range just as a little refresher. Okay, domain is left to right. So the furthest left and right this V is going to go is it's going to keep going in both directions. I have arrows, it keeps going left, keeps going right. So negative infinity to infinity. And then my range is my lowest y value up to my highest. My lowest y value is that this is going to keep going negative infinity. And then the highest y value I have is at y equals 1. And I'm going to include it with a bracket. Okay? We can use brackets on domain and range, just not on our intervals of increasing, decreasing, and constant. Okay. All right, let's look at another one. Same idea here. I'm going to go ahead and use my transformation technique. So I'm going to identify my parent function, which in this case is x squared, which we know should make a parabola. So I'm going to go ahead and make a table of values for a parabola. So I'm going to use negative 2, 0, and 2, which when I square those gives me 4, 0, 4. And then I just need to identify my transformations. I'm going to write my HSRV. My negative inside the function is a reflection. Because it's inside next to the x, I'm negating my x's, which means it's a reflection about the y-axis. About the y-axis. So like I said, we're going to negate the x's. And then the only other transformation I have is this plus 4. It's happening on the inside, so that's a horizontal shift. X's are backwards from what we think, so this is actually going to move us to the left 4. So I'm going to subtract 4 from my x's. There's no multiplication, so there's no stretching or compressing, and there's no addition or subtraction outside the function, so there's no vertical shift. So I'm going to go ahead and modify my function here. The first thing I do is move it left 4. To move it left 4, I take my x's from the previous table and I subtract 4. So negative 2 minus 4 is negative 6. 0 minus 4 is negative 4. 2 minus 4 is negative 2. And my y's stay the same. Okay. Then I do my last one, which is my reflection. So now my function looks the way I want it to. Quantity negative x plus 4 squared. And to do that reflection, all I have to do is take my x's from the previous table and negate them. Okay, so now I have positive 6, positive 4, positive 2, and my y's stay the same at 4, 0, 4. So when I plot my points over at 6, I'm up at 4. Okay. At 4, I'm down at 0. And at 2, I'm back up at 4. So notice I got a nice little parabola here. Okay. And now I just need to identify my intervals of increasing, decreasing, and constant. Here I have 2 separate intervals because it changes direction once. Okay, and it changes direction here. Notice from the left going up to the dotted line I just drew, my y values are getting less and less and less. So this is a decreasing interval. And then from the dotted line on out, notice my picture is increasing. My y values are getting greater. So this is going to be an increasing interval. So that means that we are decreasing from negative infinity up to the x value of that dotted line, which is 4. And then we're increasing from that dotted value, which has an x value of 4, on out to positive infinity. Okay. And then I want to go ahead and list my domain and range here. My domain, this parabola is going to keep going left and right, so negative infinity to infinity. And my range, my lowest y value is at 0. I'm going to include it with a bracket. My highest y value, this parabola is going to keep going north, so positive infinity. Okay. Let me look at one more, and then I will have y'all try some. Okay. This last one, I'm going to use my transformation method. Okay, my parent function here is the square root of x. So I'm going to go ahead and make an xy chart using the square root of x. So I'm going to plug in 0, 1, and 4. Remember, square root of x makes that little half parabola. Looks something like this. So it has a defined starting point at 0. It doesn't keep going in both directions. So always make sure when you're doing a table of values for this, you always include that 0 starting point. Okay, the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. So I'm going to go ahead and identify my transformations. I write HSRV. Okay, I have 3 transformations. This negative outside the function is going to be a reflection. Since it's outside, it's negating my y's, which reflects it about the x-axis. Okay, so I'm going to negate my y's. I have a plus 6 inside the function, which is a horizontal shift, left 6. So I'm going to subtract 6 from my x's to move it to the left. And then the last thing I have is a plus 4 outside, which is a vertical shift up 4. Okay, so I'm going to add 4 to my y's. Okay, I don't have any multiplication, so I have no stretching. So I'm going to go ahead and make my table here. First thing I need to do is my horizontal shift. So now I have the square root of x plus 6. To move it to the left 6, I'm going to take my x values from my parent function and subtract 6. 0 minus 6 is negative 6. 1 minus 6 is negative 5. 4 minus 6 is negative 2. My y's stay the same, 0, 1, 2. My next transformation is my reflection. So now I have negative square root of x plus 6. Okay. To do my reflection, all I do is take my y's from the previous table and negate them. So now I have negative 6, negative 5, negative 2. When I negate my y's, I get 0, 1, 2. No, I don't. I negate them. So I get negative 1, negative 2. Okay. And then the last thing I do is my vertical shift up 4. So I have the negative square root of x plus 6 plus 4. And to move it up 4, I'm going to take my y values that I just negated and add 4 to them. So my x's are still negative 6, negative 5, negative 2. When I add 4 to my y's, 0 plus 4 is 4, negative 1 plus 4 is 3, negative 2 plus 4 is 2. So I'm going to go ahead and graph my function here. So at negative 6, I'm up at 4. Right here. At negative 5, I'm up at 3. And at negative 2, I'm up at 2. Okay, so my function looks something like this. Okay. So now I just need to determine the intervals of increasing, decreasing, and constant. Notice here it's not changing direction. I don't have more than one. I only have one interval. And notice from the beginning of this function on out to the right, it's going to be decreasing because my y values are getting smaller. So that means this function is decreasing from as far left as I can go, which in this case is negative 6. Remember, we don't include it. Don't include your endpoints. Use a parenthesis. From negative 6 on out to infinity. Okay. And then I'm going to go ahead and find my domain and range. My domain, again here, it starts at negative 6. I can include it with a bracket on my domain on out to infinity. And my range, I do my lowest y value, which here this is going to shoot down to negative infinity, up to my highest y value, which in this case is 4. And I include that with a bracket. Okay? All right. So there are 2 examples for y'all to do. I would like you to work them the same way I've been working these. Use your transformations to graph the function. Once you've graphed the function, list the intervals of increasing, decreasing, or constant, and find domain and range. Okay? I'll give you a minute, and then we'll go over them. All right. So this number 1. When we identify our parent, it is a square root of x. So I made my xy table. We have 2 shifts. We're going right 3 and down 5. So once we modify our tables, we end up with, well, depending on which values you picked, 3, negative 5, 4, negative 4, 7, negative 3, which gives me a nice little half parabola over here. Okay. Notice this parabola is increasing because my y values are getting greater. So that means this is an increasing interval from 3 to infinity. Do not include that 3. Okay, we don't use our endpoints. And then we find our domain and range, which in this case, our domain, our function starts at x equals 3 and moves on out to infinity. When I look at my range, I start at my lowest y value, which in this case is negative 5, and I go on up to positive infinity. Okay. When we look at number 2, Our parent function is a parabola. It's an x squared. It's quadratic. Okay, and we have 3 transformations. We're going left 4, we're reflecting about the x-axis, and we're going up 2. So we should have 4 tables when it's all said and done, our original, and then a table for each transformation. Once we've graphed it, we get this parabola over here to the left of our y-axis. And notice our parabola, as we look at it from left to right, my y values are increasing. So this first half of the parabola up to the vertex is increasing, and then from the vertex on out to the right is decreasing. Remember, I write these intervals in terms of my x values, in terms of my domain values, and we use parentheses. So increasing from negative infinity up to the vertex x value, which here is -4, the parenthesis, and then it's decreasing from that x value of 4 on out to positive infinity. Okay. My domain here is a parabola, so it's going to be negative infinity to infinity. And my range, I do my lowest y value, which here is negative infinity, up to my highest y value, which in this case is 2. Okay. All right, so that is the end of 2.6. You should now be able to do that assignment on MyMathLab. It's just a regular assignment, no worksheet. Let me know if you have any problems.